Good morning, everyone. Today we're going to take the remainder theorem, and along with that we're going to do long and synthetic division. So let's start off. I think that learning this unit is really good if we can just keep some items in mind and notice the parallels that exist between numbers and algebra. So today we're going to learn the remainder theorem and long and synthetic division. So let us please compute the following using the long division algorithm. So it's a long division algorithm that you're very familiar with, I hope. We're going to identify the divisor, the dividend, the quotient, and the remainder. So 11 goes into 11,342 times. So I'll just do this very quickly. 11, does it go into 1? No, but it goes into 11, exactly one time. 1 times 11, both parts of 11, this one and this one, right, is 11. And choose to subtract. So I'm going to subtract. I left with 0. Carry down the 3. 11 goes into 3 exactly 0 times. 0 times 11, it's not 11, is 0. And then I'm going to subtract. What I get is 3. I carry down the 4. 11 goes into 34, both parts of 34, this part and this part. That goes into 3 times. 3 times 11, right, I'm multiplying by my divisor, is 33. I subtract that, and it is 1's left over. I carry down the 2. 11 goes into 12 exactly once. 1 times 11 is 11 with a leftover of 1. So I've run out of carry down digits, so my remainder is 1. All right, here's an interesting thought. So when we get to polynomials, sometimes I'm not very good at adding and subtracting polynomials, much better at adding alone. So here's my thought of the day. Did you know that's 7 minus 2? Let us pretend like I'm not very good at subtracting. I might get that wrong. So what I can do, though, is I can change a subtraction into an addition. That those two are equal. 7 minus 2 is the same as 7 plus negative 2. So now I'm going to do this one, but instead of every subtraction that I'm going to do, I'm going to change it to an addition. Now, the reason I know this is really impractical, but the reason why I'm going to do it is simply to prepare us for what's coming ahead. So 9 goes into 3,102 how many times? All right, let's go. I haven't answered the question. We need to identify all of these things. 9 goes into 3. Nope. 9 goes into 31 3 times. 3 times 9 is 27. So I'm going to subtract 27 from 31. Wait a second, I'm not going to do that. Instead, I'm going to add the negative of it. So it's the same process that I'm doing up here. So 31 plus negative 27 is 4. Now I know that you're probably wondering why I'm doing this, but it's to prepare us for polynomial division. 9 goes into 40, 4 times 9 is 36. I subtract it. By the way, I'm terrible at subtracting, so what I'm going to do is I'm going to add the negative. So 40 plus negative 36 is 4. I carry down the 2, and 9 goes into 42. 4 times 9 is 36. And I have, to subtract those. Again, I'm terrible at subtracting, so I'm just going to simply add negative. And what I should get is a remainder of 6. So now let's talk about things. life and such. What is the divisor? The divisor in this question is 9. The divisor can be found in the long division algorithm right here. The dividend. What's going on? The dividend. Good question. What is the dividend? Highlight that in green. The dividend is just simply the number under here. Please note this down. The quotient is this result up here. Now, one of the and I believe that was a 4 there. Last but not least is going to be my remainder. Now, where can I find my remainder? My remainder can be found right there. All right. So, I'm going to do an example of long division. I'm going to do polynomial long division, and then I'm going to describe the setup. I'm going to use words like divisor, dividend, quotient, and remainder. These are really very important words that we should concentrate on. If we know the vocabulary, we can better describe what we're doing. So my quotient here, well, better change. There we are. I'm going to change to black. My quotient, I'm going to put on the left side. There we have it. X minus 2 goes into x to the power of 4 minus 2x cubed minus x squared plus 7x minus 4. I'm just going to get rid of that ugly blue part. So let us carry on. Switch colors to green. I have to change my words a little bit over here. So the words that I'm going to change, I'm not going to ask myself how many times does x minus 2 go into this. Instead, I'm only going to concentrate on the first term. X times what gives me x to the power of 4. That is equivalent to saying x goes into x to the power of 4 how many times? That's a great question. X times what gives me x to the power of 4? That is x to the power of 3. Please focus on changing the words. If you don't, you'll likely get it wrong. Now, what I'm going to do on my way down now, just like with the long division with numbers, x to the power of 3, I'm going to multiply it by my whole divisor this time, just not the first term. So I get x to the power of 3 times x gives me x to the power of 4. X to the power of 3 times negative 2 gives me negative 2 x to the power of 3. Just like long division with numbers, you need to subtract this. Now, I've always claimed that I'm terrible at subtracting, and here, this is what you're sort of seeing. We need to subtract the green from the black. So what I do, instead of subtracting, I change this to an addition sign. And I make the thing that I'm subtracting the negative. So now I can just add those, x to the power of 4 plus negative x to the power of 4, that's 0. Negative 2x cubed plus 2x cubed, well, that's just 0x cubed. And then I carry down my x squared, so minus x squared. Now here, again, I ask myself, x goes into x to the power of cube. Well, wait a second. X times what gives me 0x cubed. Now only looking at the front. Well, that would be 0. 0x squared if you want. 0x squared times x gives me 0. 0 times negative 2 also gives me 0. So really what I carry down is negative x squared. And I did that so fast because really I can change it so I would be adding negative 0. First terms cancel out. Negative x squared minus 0 is negative x squared. So now I'm going to carry down that positive 7x. Now, switch to red. I ask myself, x goes into only the first one. X times what gives me negative x squared? Well, that's positive x. Now, on the way down, remember, you have to multiply both terms of your divisor. X times x. I think I messed that up, right? I just realized I messed that up. How did I mess that up? Let's revisit the red. Here we are. X times what gives me negative x squared? It should be negative x. Negative x times x gives me negative x squared. Negative x times negative 2 gives me positive 2x. So now, I'm terrible at subtracting. I need to subtract this, but I'm terrible at it. So what I'm going to do is I'm going to add the negative. Negative x squared plus x squared is 0. 7x minus 2x is 5x. Guess what we're going to do? We're going to carry down that negative 4. And wouldn't you know what? We've run out of steam here. We've run out of terms. X goes into, or x times what gives me 5x? Well, hopefully you say 5. 5 times x minus 2, well, remember to multiply it to both terms, is 5x minus 10. Now, you may want to complete that out. Okay, I hope you tried, but I'm going to add the negative instead. So I have a remainder of 6. My quotient is x cubed minus x plus 5. My remainder is 6. My divisor is x minus 2, and my dividend is this polynomial here. Fair enough. So let's just take, for instance, I'm just going to play around with numbers before I get to this setup of long division. If I take interesting things like 4,021 divided by 7. Now notice what I do not do. Everybody's going to say, well, you just set it up like this. What's so hard about this? Well, that is correct. I will do something wrong. Why am I do not forget that 0? After all, that means 0 hundredths. Well, the way that we work with math often is that we have to have this placeholder of 0. Right? So we can't forget zeros. That's kind of important. The second thing that we can't do is, so I cannot arbitrarily say, well, that's 4,021 divided by 7. Well, that goes into 7, goes into... I can't jumble up the terms. Here, the 4 is in the thousands place, the 1s is in the hundreds place, the 2 is in the tens place, and the 1 is in the ones. So very similar to long division. Now, the setup for long division, I always believe that it's best to practice this to learn it. to have thorough notes. It would take forever to do it. We just do it. So the setup for long division, I am going to say terms in divisor and dividend must be in descending order of degree. Now that's important. So what does that mean? If you notice, if you take, here's my dividend, my exponent started off with 4, and then we went down to 3, then we went down to 2, and then we went down to 1, and then we went down to 0. That's the way I wrote out my long division algorithm. In algebra, often we're able to mix all of these up, and that is still the same quantity. It doesn't really strike us any different, but when we do the long division algorithm, we have to make sure that they are in descending order. Same with the divisor here. This has to be x to the power 1, and really that's x to the power of 0. And I'm going to say we have to include 0 coefficients. So we need to include 0 coefficients. Apologize that my writing's so messy today. What I mean by that is if we have a term that is 0, we have to make sure that we include that in the long division algorithm. Is there anything else that I'm missing? No, maybe, just maybe, you may want to make a comment of changing the language. Instead of how many times does x go into x to the power 4, you may want to say how x times what gives me x to the power 4, right? So that'd be your quotient, your dividend, your divisor, your dividend, and your quotient. All right, good times. So I just want you to set this up. Press pause to set this up properly by paying attention to this. Press pause, do it. So, although this is not a necessary step, I think that this is a smart step. Simply, this is not in descending order of degree, so I'm just going to do that. And when I'm writing it down, x to the power 3, I notice that there's no x squared term. So I'm going to include the 0 coefficient there, plus x minus 7. And very quickly, I can set this up using the long division algorithm. There. That's how I would set it up. And if I wanted to start this, I can start the process. So I'm just maybe going to try to focus in on that and get going. X times what gives me x cubed? Well, x squared. X squared times my dividend, or my divisor, I have to multiply both terms. This ends up being x cubed, right? X squared times x gives me x cubed. X squared times 1, positive 1, gives me x squared. I'm going to put that in brackets, and then I'm going to subtract them. Terrible at subtracting, so I'm just going to simply add the negative. Those cancel out. X squared minus x squared, or sorry, 0x squared minus x squared gives me negative x squared. Carry down the 1, or sorry, carry down the x. X times what gives me negative x squared? That should be negative x. Negative x times both terms of my divisor end up being negative x squared minus x, right? Negative x times 1 is negative x. I'm going to subtract that. I want to add the negatives. Wouldn't you know it? Wouldn't it be nice if they don't? Negative x squared plus x squared is 0. X plus x is 2x. Carry down the negative 7. What times x gives me 2x? 2. 2 times x plus 1 gives me 2x plus 1. Sorry, incorrect. Now this is a common mistake. 2 times x gives me 2x. 2 times 1 gives me 2. I have to subtract this. So instead of subtracting, I change it to the negative. And what we get is a remainder of negative 9. So my quotient is x squared minus x plus 2 with a remainder of negative 9. And we'll see how we can write this later on.